video, we're going to be looking at a 7-day rolling average of stock prices. So the problem is we're given a sequence of daily stock prices and we want to compute a 7-day rolling average for these prices. So basically a weekly average. So our input is a list of different stock prices in order. So if we look at the first 7 days, which are the values 1 through 7, if we were to take an average of that, we would get an output of 4. If we were to take an average of 2 through 8, we'd get an output of 5. If we were to take an average of 3 through 9, we get an output of 6, and so on. So how do we take an average? Well, all we do is we sum the 7 values and then divide them by 7. So that's how we get 4. Then we sum the next 7 values, divide them by 7. That's how we get 5. So we can jump right in and we can start by doing exactly that. So you should always be able to come up with some type of brute force solution. So the first thing we need to do is take the sum of the window, which our window is going to be the length of 7 because we're taking a 7-day rolling average. So if we look at our window sum, we just take the first 7 values and sum them up. So we go through the stock prices up to the 7th index. And then our rolling average, which is what we're going to be outputting. Our rolling average is going to be a list, and we already know the first value that's going to be in the list, right? It's the window sum divided by 7, because that's the average of the first 7. Then all we need to do is fill out this rolling average list. So originally we started, our first window sum here is values 1 through 7. Now we need to compute the sum of values 2 through 8. So for I in range of 8 to the length of our list, which is stock prices, plus 1, what do we need to do? Well, we need to take the window sum and make it equal to the sum of the stock prices from I minus 7 up to I. And then what do we do to take the average? Well, we put them in our list, and the average is, of course, just the window sum divided by 7. And then all we need to do is return the rolling average. So if we were to run this now, we should pass. And we do, of course. But what's wrong with this? Well, you can see there's a big inefficiency here, right? Because first thing we do is we calculate the sum of the first 7. Then we compute the sum of the next 7. Well, every time we already computed the sum of 1 through 7, right? And then, so we're computing 1 plus 2 plus 3 plus 4 all the way to 7. Then we're computing again 2 plus 3 plus 4 plus 5 plus 6. You can see there's a lot of overlap, right? So how can we make this more efficient? Well, if you think about it, we sum the first 7. What's the next window? The next window is 2 through 8. So how can we get that sum knowing that we already have the sum of 1 through 7? Well, if we just subtract the 1 off and add the 8, we can keep all of this overlap that we had before. So we don't have to recompute things that we are already computing. And then if we do this again, we want to take the next window, right? We'll have to remove the 2 and then add the 9. And then that's how we'll get the sum of 3 through 9. So how do we modify this? Well, instead of taking the sum, repeating the sum like this, we already know our window sum from before. And then we can subtract the earliest value that's in the sum. And then we can add the next value that we're looking at. Now, of course, for this, since our indexing is off a little bit, we'll just need to go from range of 7 to the length. And you can see here, and now every time we have the window sum, we're subtracting the earliest value that's within the window and adding the next value that needs to be in the window. And that's why they call it a rolling window, right? Sliding window. So if we run this and that passes. So the main takeaway here is the sliding window technique, right? So when do you use the sliding window technique? It's usually when you have a window of values and then you're going to slide that window over just like we're doing. And there's some type of computation that happens when you slide the window that can be, you can use the computation from the first window to come up with the computation for the second window. So in our case, we had the sum of 1 through 7. We would have to recompute the sums 2 through 6, but since we are doing it in a smart way now, we're no longer doing that. We're just subtracting the earliest value, adding the next value. So what's the time complexity for this? Well, it's just a linear path, and this is going to be big O of n, where n is the length of the stock prices. If we weren't using the sliding window, it'd be big O of n times k, where k is the size of your window, right? Because every time you slide the window over, so you're going to do potentially n slides, but then you have to recompute a window size of k, so it'd be k times n, where here all we're doing is, yeah, we're sliding the window n times, but we're subtracting off a single value and adding on a single value, right? We're subtracting and adding a single value. So that is going to be a time complexity of big O of 1 for adding and subtracting. Because no matter the size of our k, the size of our window, we're just going to always add 1, subtract 1. So our total time complexity is big O of n, where n is the length of the stock prices.